All right, so this is Module 3, Lesson 2. We're going to talk about area a little bit more this time, but we're going to talk about areas of composite figures. And a composite figure is really a figure that's made up of multiple shapes, and you would find the area of each shape and then add them together. So if you take a look at these two opening exercises, it says find the area of the figures by decomposing them into other shapes. So really, decomposition just means take this trapezoid we've got here on the left and say, you know what, I can draw a line right here and turn that trapezoid, or at least that one, into a rectangle and a triangle. But I will admit right now, one thing that we forgot to put in the notes here is that these are right angles, by the way. It's not stated explicitly, but I'm telling you now. So that's a rectangle and a triangle. So if I wanted to say, you know, forget that I knew the area of a trapezoid formula and say, you know what, this trapezoid is really this rectangle plus this triangle, I'd say, well, this rectangle right here, that rectangle is going to be 12 times 14 for base times height. And then this triangle over here, well, if that was 14 on top and this is 22 on the bottom, that means this is 14 and this is 8. And if I've got 12 over here, that means that this is also 12. So the area of the triangle is 1/2 times 8 times 12. So if I find both areas and add them together, I will have the answer to our problem. So 12 times 14 is 168, and 1/2 times 8 times 12 is 48. And the area of the two things would just be the sum of those two values for a grand total of 216. Now, composition is only one way to do it. We could erase all this nonsense I drew on here and say, well, why would I decompose it? I know the area formula. That's fantastic, all right? So if you remember the area formula, we said yesterday that the area of a trapezoid is h over 2 v1 plus v2, where your height is 12 and your bases are 14 and 22. And if you type that into your calculator, you really have 6 times 36, and that is also 216. So it's really just another way to get at the same answer when you have a figure that actually has its own area formula. So I'm going to come over here, this thing right here. Again, one thing we forgot to tell you is that this is a regular polygon. It's actually a regular 1, 2, 3, 4, 5, 6, 7, 8. It's a regular octagon. So one way to get at the area here is to say the area of a regular polygon is 1/2 AP, where A is the apothem and P is the perimeter. So if we use the old formula, it's 1/2 of 14.49, I'm running out of room, times, let's see, the perimeter, which would be 12 times 8, which is 96. So 1/2 AP would be 1/2 of that. And if I type this off screen here, I ended up with an area of 695.52. Well, that's not the only way to get there. And you've never seen the 1/2 AP formula, so there's a good chance you might forget it. So the other way to get at this is to say, let's ignore the formula and say, really, this is 8 different triangles. Okay, I have 8 different triangles. Well, each triangle has an area of 1/2 base times height. So if each triangle has an area of 1/2 base times height, then each triangle, I'm typing off screen, then each triangle has an area of 86.94. That's one triangle. Well, I have 8 triangles. So if I multiply that by 8, I get 695.52, which is exactly what we got in the first place. So basically, what we want you to get out of this opening exercise is that you can take a figure, decompose it into other figures, and still get the same area. Now, one of the reasons I picked those two is the newest formulas you've seen are the area of a trapezoid and the area of a regular polygon, and then the rhombus cube height. So where would the area of a trapezoid come from? I'm going to do this really creative, awesome thing. So let's say I have a trapezoid, okay? And my trapezoid looks something like this. and I tell you that these guys are parallel, so there's a trapezoid. What if I broke this up and I said, well, you know what, the area of a trapezoid is h over 2 b1 plus b2. That formula kind of looks like it came out of nowhere. Well, actually, it didn't come out of nowhere. It came from somewhere. Let's say I cut the height in half, just like this, and then I come up, over, and down with this piece. Okay, there's one piece of the trapezoid. And then I take a second piece of the trapezoid, and I do it like that. Watch what I can do with these pieces. Well, when I take this piece, I'm going to pull it off to the side here. This top part used to be B1. And this thing right here was half my original height, right? And now I take the blue piece, I bring it over here, and watch what I can do with this. Ready? Come on, spin. Whoa. Look what happens when I line these two things up. Okay, hypothetically, what's that? Look what happens. Now, if I was a better drawer, what you should really see right now is you should see a rectangle. That piece right there was B1. This big piece on the bottom of the blue came from here. It's B2. Now I have a rectangle. And my rectangle has an area of base times height. And the base is B1 plus B2. And the height is half the height of the original trapezoid. The area of a trapezoid comes from the fact that a trapezoid is actually made up of two pieces that, when put together, make a rectangle, or technically a parallelogram. And the area of the parallelogram is half the original height times the sum of the bases. So there you go. It's kind of a cool thing to know. Area of a trapezoid comes from there. Now, area of a regular polygon, we actually just talked about this. So if I take a regular polygon, which I can get one up here, let's do a pentagon. If I want to find the area of a regular polygon, instead of using that 1/2 AP, I can just say, you know what? A polygon is made up of a whole bunch of triangles, right? So if I take this thing right here, I take this triangle, if I were to repeat it 5 times, I take this and I make it an infinite cloner. I take this triangle and I pull it over here, but then I turn it so it points to the middle. Look, here's a triangle, right? And then I take this guy and I bring him up over here, and again I need to turn it so it points to the middle. You can see what I'm doing here. I could have 5 of those triangles. Well, each triangle has an area of 1/2 BH. But technically, my B is right here, and my H is the apothem. So I have 1/2 BH, but I have 5 of those. Well, if I rewrote that and wrote it as 5B times H, because I can do that, it's the commutative property of multiplication. 5B means 5 bases, 1 base, 2 base, 3 base, 4 base, 5 base. 5 bases is my perimeter, and the height is this, which we talked about the other day, is really called the apothem. This becomes 1/2 AP. So the area of a regular polygon, being 1/2 the apothem times the perimeter, really comes from the fact that your perimeter is a way of adding all of these triangles together, all the bases of those triangles together. All right, and then last but not least, talk about the area of a rhombus and a kite. So if I want to find the rhombus and a kite, I'm going to just do it with the kite because it's easier to draw for me. So if I have a kite, and it looks like this, and I have this as D1, D3, and then I'm going to call this a D2 and D4. A kite is really made up of 4 triangles, right? This triangle, this triangle, this triangle, and this triangle. 4 triangles. So let's say I find the area of all 4 triangles. Well, this one right here on the left would have an area of 1/2 D2 times D1. And then this guy on the right would have 1/2 D2 times D3. And then the 2 on the bottom would be 1/2 D1 times D4, 1/2 D3, this guy, times D4. All right, I'm going to get a little crazy on you here. If I have 1/2, all these things right here, look at these two on the top. If I look at just these two on the top, they each have a 1/2, and they each have a D2. So I can pull out the greatest common factor and say 1/2 D2 comes out, and then I'm left with D1 times D3. I'm sorry, times D1 plus D3. Right? Because I'm pulling these pieces out, leaving me with just D1 and D3. Well, D1 plus D3 is basically the horizontal diagonal, because D1 plus D3 is this thing that I'm scribbling right now. I do the same thing on the bottom. I can pull out 1/2 D4, and I'm left with D1 plus D3 again. Okay? So I now have 1/2 D4 times D1 plus D3 plus 1/2 D2 times D1 plus D3. And if anybody remembers grouping from last year, yes, I said last year, you still need to remember all your algebra stuff. I can now pull out another GCF of 1/2 D1 plus D3, which will leave me with D4 plus D2. D1 plus D3 was our horizontal diagonal. D4 plus D2 is our vertical. Okay, wow, this crazy lady on the video just did a whole bunch of nonsense that you didn't understand. If you understood it, that's fantastic. If I lost you, it's okay. I just want you to understand that these figures are formed up of other pieces. And when you add them together, that's where the math gods decided to get their formulas. 1/2 the product of the diagonals. Okay. That is where I will leave you, and you can do some practice with your teacher. And I always end with a joke, so what joke do I want to tell today? What did the infinity say to the 8? Help, I've fallen and I can't get up. Bye.